Hi everyone, welcome to the channel, the brand new channel, Student the Brand. So this is Shiva. We are going to learn magnet effects of electric current, right? Yes. So what is the magnet effects of electric current? So this is a convex and concave lens. Yes. So this is physics shirt. So we are going to discuss about the topic. Let's start the topic. So the first magnet is magnetite, that is natural magnet. The natural magnet comes from earth crust, that is magnetite, comes from the name magnesia. Okay, so the origin of the magnetite is, or the name is magnesia. From that we are considering the magnetite, that is a natural magnet, right? It occurs in the nature, and there are so many artificial magnets are there. So bar magnet, u-shaped magnet, dumbbell magnet, like that, so many we are considering. Okay, so what is the meaning of the magnet effects of electric current? By passing the electric current through the conductor, it shows, it behaves, it acts as a magnet. If the current is passing through the conductor, it acts as a magnet. So in lower classes we have done one activity, that is, so you take the nail, so nail will be there here, then so we are wounding the copper wire around it, that will be connected to the battery, so current will pass through it, right? Current is passing through the, so positive terminal, negative terminal, current is passing through it. So it acts as a magnet. It behaves as a magnet. Acts as a, it behaves as a magnet. So that is the meaning of the magnet effects of electric current. By sending the current through the conductor, producing the magnetic field. So that is about magnetic effects of electric current. Now, before getting into the topic, so we will study about magnet. Okay, so what is a magnet, how the field will be there around the magnet, so where exactly it will be, and how the field lines will be there, all these points we'll discuss now, right? So if you the magnet have two properties. One is directive property. If you hang the magnet freely, if you hang the magnet freely, always it suspends north and south, always. So little bit points. So if you are taking, this is north and this is south, this is east and west. So north, south, east, west. So it shows somewhat inclination. So like this, somewhat inclination. It will show like this. If you suspend the magnet, so little tilted. Okay. Next one, attractive property. So if you take a repulsive property also we can see. So if you are taking, so this is one magnet, this is the north pole and this is south pole. This is one more magnet, this is north pole and south pole. So two same poles will repel each other. Two same poles will repel each other. Two different poles will attract each other. Two different poles, like north and south, south and north. So these two are different poles. Okay, so both will attract each other. Both will attract each other. Clear? So both will attract each other. So north pole repel each other. North pole repel each other. South pole will repel each other. Okay, so this is about the properties of the magnet. Now, how the magnetic field will be there? How the magnetic field will be there? How the magnetic field will be around the magnet? So, in the form of what? So, what are their properties? Now, we will discuss. So, now you can consider this the north and south, sorry, that is nothing but north pole and south pole of the bar magnet. So, I consider a bar magnet. So, this is a bar magnet. So, here I am considering the field lines. So, this is the field you can consider. So, one, I am taking one more. Yes. So here you can consider like this. Yes. So how the field will be there around the magnet? So if you take this so you consider this a magnet. If you drop into the sand, then what happens? So at the ends, so here and here, the magnetic materials like iron fillings will be attracted. So here and here, right? Iron fillings will be attracted. So where it will attract more? At the ends of the bar magnet. At the ends of the bar magnet, the iron fillings will attract. The iron fillings will attract. So at the middle, it will be less. The attraction will be less in the middle. So at the ends, the attraction will be more. So here I'm considering. So this is the consider. So these are the poles. These are the poles. So magnet. So north pole and south pole, right? So that's the reason at the poles the attraction will be more than in middle. Than in middle. So the field around the magnet. What is a magnetic field? Magnetic field is nothing but the region around the magnet. So I'm considering this the region. So within the region in which the magnetic force exerts. So once again I'm repeating the definition. What is the magnetic field definition? The region in which magnetic force exerts or influence the magnetic materials or exert force on magnetic materials is known as magnetic field. Once again, the field in which magnetic force exerts on magnetic materials is known as magnetic field. Magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. So here you can see the field lines always direct from north to south. Starts from north and reaches to south pole. So here like this. I'm considering like this. Right? So here you can take like this and reaches to the south pole. Reaches to the south pole. Like this you can consider. So the direction. Okay. So direction if you place like this, it appears good. It looks good. The diagram is neat and clear, proper. So you'll get good marks in the exam. Right? Yes. So the first point is magnetic field lines start from north and reaches to the south pole. Always these magnetic field lines are closed loops. Magnetic first point is magnetic field lines are closed loops. Second point, so it starts from north to south, and these field lines never intersect each other. These field lines never intersect each other. So I already said, so magnetic property, so that is, so it always shows north and south direction. North and south direction. Even if you place compass, so inside of the compass a small magnetic needle will be there. Okay, so it's made up of magnet. It always shows north and south direction. So if the field lines intersect each other like this, at the point of intersection, magnetic field, that is nothing but compass. If you place compass, so compass should show two directions at a time. Two directions at a time. So where it is not possible, right? So the direction of the magnetic field lines at particular point, if you want to find the magnetic field line, so directions, how we can find out? If you draw a tangent to the curve like this, at that particular point along that direction, the field lines will be there. So I said north to south, along that point only we have to draw. Sir, you are asking about the tangent, so can we draw like this? No. So the magnetic field directions north to south. So why along the tangent? Every time, in this point along this tangent, in this point along this tangent. So every time the direction of the magnetic field point to point it changes. But overall you can consider the magnetic field lines will be from north to south. North to south. So that is the reason if you draw tangent to the curve, then at that particular point along the direction of the tangent the magnetic field will be there. at the particular field only, at that particular point only. Overall, you can consider north to south. So clear? Once again, I'm repeating the points. So overall points are same only. The order changes up and down. It's fine, no problem. So just try to note down all the points. Point number 1. So what is that? Magnetic field line starts from north and reaches to the south. Second point is always magnetic field lines are closed loops. Third point is these magnetic field lines never intersect. If intersect, so compass should show at the point of intersection in two directions. So at this point, compass should show two directions where it is not possible. Clear? So this is about the magnetic field and magnetic field lines, properties of magnetic field lines. So this is about this video. In next video, we will discuss more about it. Thank you so much. Like, share, and subscribe. If you like the content, the way of teaching, please give a thumb to get motivation. So if you have time, you can comment also. If you have time, you can share it also. Still you like it, you can subscribe my channel. Thank you so much. Your student the brand.